So if we need to graph y equals tangent of 5x, you'll want to think about the key characteristics of the graph. So one thing is the asymptotes. Like these are the asymptotes you can drag around in Newton. So y, I'm going to rewrite this as y equals sine of 5x over cosine of 5x, because tangent is just sine over cosine. And then you want to find out where divide by 0 errors happen, because if you figure that out, then you have asymptotes, right? So cosine of 5x equals 0. To figure out what this is, we can note that cosine, since it's the x-coordinates in the unit circle, cosine is 0 here and here. So cosine is 0 at pi over 2 and at 3 pi over 2. So we need the inside to equal pi over 2, so that cosine of 5x can equal 0, and so that we have those asymptotes. So that's just a quick little equation now. We need the whole inside to equal pi over 2. So to solve that equation, just multiply both sides by 1/5. So we got x equals pi over 10. And then we also need to solve for 5x equals 3 pi over 2, so that means x equals 3 pi over 10. So those are asymptotes. Let's see. And then there's also negative places where the asymptotes are going to happen too. So you'll want to keep those in mind when you try to make the graph. To find those negative ones, think about the negative rotation. This is a negative pi over 2, and then this is a negative 3 pi over 2. So let's just do 5x equals negative pi over 2, just because of the restriction we have of the graph. We don't have a very big graph. If you solve this, x is negative pi over 10. So the two closest asymptotes to 0 are x equals negative pi over 10 and x equals pi over 10. So let's drag these. That's 5 pi, x equals pi over 5. I don't see pi over 10 yet. So maybe we zoom in. I guess this is 5 pi. Sorry, if this is pi over 5, then half that distance should be pi over 10. Okay, so it doesn't have it labeled, but this is pi over 10 right here, where I have my asymptotes. And then we got to drag this somewhere so that we have a dot. So to make that happen, we just need to know a particular value for y equals tangent of 5x. So one way we can do that is there's a special value that we could keep in mind with tangent and cotangent. Tangent of x equals 1 when x equals pi over 4, and I can show you why that is. So here's pi over 4, right? And if you were to draw that special triangle, it's a 45-45 triangle, because pi over 4 is 45 degrees. So it means the opposite and the adjacent are the same thing. The opposite divided by the adjacent equals 1. So when x is pi over 4, so on the x-axis, we got to find pi over 4. We're going to get 1. Oh, let's see here though. Pi over 4 isn't going to fit in between those two asymptotes. What's another one we could get? Something that'll fit between those two. Okay, I know what I'm missing here. So when x is pi over 4, tangent of x equals 1. But we're dealing with tangent of 5x. So we need to set this 5x equal to pi over 4. And if you solve that equation, x equals pi over 20. Okay, so again, this comes from a known value that if tangent is tangent of pi over 4, that always equals 1. So we need to solve for x in this equation so that the inside equals pi over 4. And when we solve that equation, get pi over 20 for x. So pi over 20 for x, 1 for y. That's our graph. Let me me see if I can pull up another one. So if we need to graph something more complicated here, we can stick with the same strategy. We can find the asymptotes first. And the asymptotes happen when we're having a divide by zero problem. Right, so 2 tangent 4x plus 2 pi over 3. Let's focus on this here. And let's try to find out what's going to cause a divide by zero error. So I'm just going to jump right to the fact that tangent is sine of 4x plus 2 pi over 3 over cosine of 4x plus 2 pi over 3. So when the denominator equals 0, then we have a divide by zero error. So to figure out what that looks like, we're again thinking about what makes cosine equal 0. Cosine are the x coordinates. This is 1 comma 0, so cosine is 1 at 0 degrees. So in the unit circle, if we go up here, this is 0 comma 1, cosine is 0 when we have a pi over 2 angle. And then the other place we've said before is 3 pi over 2. Okay, so we want to set the denominator equal to 0 so that we can find the asymptotes. We want that to equal 0, so that means inside has to equal pi over 2, or remember the other option is you could have negative pi over 2. That's another way of saying 3 pi over 2. They're the same angle. They have the terminal side that's the same. So we want to set the inside of this equal to 4x plus. We want to set the inside equal to pi over 2 and solve that equation. And then we want to set the inside equal to negative pi over 2. And then to solve this equation, we'll take the top one up here. You would subtract 2 pi over 3 from both sides. Run out of room. Oh, there we go. That's better. Okay, so I'm going to subtract 2 pi over 3 from both sides. And I'll do the fraction out for you this time, and then the other one will kind of go past it a little quickly. We need common denominators in those two fractions. So this is 3 pi over 6, and this is 4 pi over 6 when we get common denominators. And so now if we subtract those, then we have negative 1 pi over 6. And then to get x by itself, just multiply both sides by 1/4. So you get negative pi over 24. Okay, and then over here, if you try to solve this equation, do the same type of thing. Subtract 2 pi over 3 from both sides. So you get 4x equals, this is negative 3 pi over 6, subtract 4 pi over 6. This is negative 7 pi over 6. And then multiply both sides by 1/4. So you get x is negative 7 pi over 24. So let's see about graphing those asymptotes. Negative 7 pi over 24. I don't know if it's going to let us do those. So I figured out why Newton isn't giving us the asymptotes that we found. It's because they want us to place the center of the graph first. Okay, so let's talk about what these and these numbers do. We said tangent of x originally looks like this for a graph, right? So this is had a phase shift done to it, and it's been shifted vertically down 2 units. Okay, so to figure out where we've ended up, we actually have to rearrange a bit because the phase shift is found after you factor out the coefficient of x. So we need to rewrite it like this. And now what is this going to look like when we factor out a 4? This is 2 pi over 3 times 4. Okay, because now if you were to factor the 2 back in, the 4's would cross cancel and leave you with 2 pi over 3 like it's supposed to. So if we simplify that a bit, There's our phase shift. It's a plus. Oh, sorry. If you actually could simplify a little bit more, couldn't you? This is 1 pi over 6, I should have said. So pi over 6 here. Okay, so pi over 6 units to the left. It's opposite of what we think. Remember when we looked at the graphs of sine, cosine. So our phase shift moves us from the origin to over here to pi over 6 units to the left. Oh, I can't make that graph happen. There we go. But this is our vertical shift. We've gone down 1 unit too. So this is where the graph should have that point where it kind of switches directions. Like this is our origin. Our origin gets shifted pi over 6 units to the left and 1 unit down, so that now this is our origin. Okay, so let's go into Newton and make that phase shift happen. There's our pi over 6 units to the left, and there's our 1 unit down. And so now you can see my asymptotes working out. We said negative 7 pi over 4 was one of them, and negative 7 pi over 24 was one, negative pi over 24 was the other. So now the last thing we need is a dot. Okay. Where's our 1? So if you drag this up and down, first we know it's got to be one of these points right here, not one of these points, because that changes the direction of tangent. Right? That would only happen if this is negative 2 tangent of x. Okay. So to figure out which one of these it's supposed to be, really all you can do is plug in negative 0.327 in for x in here. Okay, so negative 0.327, and see what the y coordinate is that comes out. Just make sure your calculator is in radians. Okay, so if we do that, I'm going to simplify 4 times 0.327 when it's negative. Gives us negative 1.308. And then we need to add 2 pi over 3. So to figure out what that is, we're going to do 2 times pi. Divide by 3, and then add the negative 1.308. Okay, so make sure you're in radians. This is what the inside of our parentheses simplified to be, so we can hit trig tangent, multiply that by 2 like the equation says to do, and then subtract this result by 1. So at negative 0.327, we got approximately 1 for a y coordinate. Okay, so that last part's kind of tricky because they're looking for a specific dot. They only have one x coordinate for you to test out, so you just got to plug in whatever the x coordinate is and solve.